and the rate of chemical reaction and equilibrium. And rate of chemical reaction. What is meant by rate is a change per time. Change mass per time, volume per time, or concentration per time. And the rate affecting speed, not amount. What is meant by affecting speed, not amount? In case of two reactions, one of them has faster rate and the other one has a slower rate, the difference in the time, the more steeper as faster rate. What's meant by faster rate? Takes less time, and slower rate takes shorter time. But both of them have same final amount. So the difference in the timing, not in the amount. There is factors affecting rate of chemical reaction. Temperature, pressure, concentration, catalyst, surface area, and nature of reactants. In temperature, particles gain kinetic energy. So particles moves faster and more successful collisions per unit time. So faster rate of reaction. In case of pressure, in pressure and concentration, particles get closer. So they have more collisions and faster rate. And a catalyst provides alternative route or alternative pathway by lowering activation energy. What's meant by activation energy is the minimum amount of energy to start the reaction. So the catalyst lowering activation energy, the amount of energy needed to start the reaction. And surface area, by increasing surface area to be powdered instead of blocks or sheets, more surface area. And nature of reactants depends on the time that we have solid, liquid, or gas, the states. All of these factors are directly proportional. By increasing any factor, the rate of reaction increases. So by increasing temperature, pressure, concentration, catalyst, surface area, and nature of reactants, the rate of reaction increases. To be faster rate or slower rate, they change only in the timing. For example, if you have reaction A, this is the original, and we have reaction B and reaction C. In the front of 40. And we have reaction D in the front of 80. And reaction E in the front of 20. And reaction A, this is the original. Reaction B and C, B slower rate and C faster rate. Faster rate like increasing temperature, adding catalyst, use powdered instead of blocks or sheets, like that. So this is the faster rate. Slow rate is the opposite, decreasing temperature, removing catalyst, using blocks or sheets instead of powders. In D, double concentration are used. In E, half concentration is used. So double concentration, so reduce double amount of the original. Half concentration produce half amount of the original. So if we have faster or slow rate, it's the same ending. But in case of double amount, this means that double concentration, or half amount means half concentration. For the rate of reaction, for example, if you have this volume with time, if we need to calculate rate at A, rate at B, and rate at C, you will find that rate at point A, maximum. Explain why it's maximum. Concentration of reactants, 100%. At B, decreases gradually. Why decreases gradually? Because concentration of reactants decreases. How comes to be decreased and it is moves forward? Moves forward is the volume with time, not the rate. But the rate decreases as the concentration of the reactant decreases. At C, rate equals 0, minimum. Why? All reactants are used up. Reaction is finished. So, rate to be maximum at the beginning because the concentration of reactant 100%. Then rate decrease gradually as the concentration of reactant decreases, and then rate becomes stopped or equals 0, all the reactants are used up, reaction is finished. After that, we have equilibrium. What's meant by equilibrium? Equilibrium takes place in reversible reactions. The reaction proceeds in two directions, forward and backward. An equilibrium takes place when the rate of forward reaction equal rate of backward or reverse reaction. So rate of forward equal rate of backward or reverse reaction, and the concentration of reactants and products still constant, no more longer change. And equilibrium affecting amount, not speed. How comes to affecting amount? As the reaction moves forward, it means more yield or more product is produced. And as the reaction moves backward, it refers to less yield. For reversible reaction, to make the reaction reversible, we must have, number one, no evaporates. Number two, no precipitates. Like, number one, if we have N2 plus 3H2 gas to NH3 as a gas in open container. There is no reversible reaction. Or if we have reaction NaCl plus AgNO3 gives NaNO3 plus AgCl as a solid precipitate, no reversible reactions. While in case of N2 plus 3H2 enclosed container gives NH3, this closed container. So in this case, we have reversible reaction. Factors affecting equilibrium. Concentration, pressure, and temperature. In case of factors affecting rates, we have temperature, pressure, concentration, catalyst, surface area, and nature of reactants. But in case of factors affecting equilibrium, only temperature, pressure, and concentration. For the first one in concentration, by increasing concentration, the reaction moves from high concentration to low concentration. While in pressure, from more number of moles to less number of moles. And must be for gases only. In temperature, by increasing temperature, it depends on if the reaction is endothermic or exothermic. So for concentration, by increasing concentration, the reaction moves from high concentration to low concentration, while for pressure, from more number of moles to the less number of moles, while for temperature, from endothermic to, depends on endothermic or exothermic reactions. Number one, concentration. Concentration for liquids, like if we have CH3COOH plus C2H5OH, forming CH3COOC2H5 plus H2O. In this case, how we make the reaction moves forward? To make the reaction moves forward by increasing the amount of reactants or decreasing amount of products. The reaction moves forward and more yield is produced. So if we add more CH3COOH, if we add more CH3COOH or C2H5OH, or by removing CH3COOC2H5 or H2O, the reaction moves forward. When the reaction moves forward, it means that more yield is produced. For the direction, when the reaction moves in this direction, this means that this amount will be less and this amount will be more. So according to the direction of the arrow, if the arrow moves forward, product increases. If the arrow moves backward, opposite direction, so the reactance is increased. This is number one. Number two, pressure. Pressure for gases. It depends on the number of moles. If the number of moles number one, in reactants is greater than products. Number two, if the number of moles and reactants less than products. Number 3, if the number of moles of reactants equal products. Like, for example, if we have N2 plus 3H2 gives 2NH3. 2SO3 gives 2SO2 plus O2. H2 plus I2 gives 2HI. The number of moles of reactants, the coefficients that we have, 4, 3, and 1. The coefficient 2. Coefficient 2, 3, 2, and 1. 2 and 2. In case of the number of moles of reactant is greater than products, by increasing pressure, reaction moves forward. So if we are increasing, moves from 4 to 2. This is the first one. And second one, if the number of moles of reactant is less than products, if we are increasing, it moves backward. So we need to decrease to make it move forward. Again, if you are increasing, moves from 3 to 2. But if you are decreasing, moves forward. What is the advantage in each case? Here the advantage by increasing moves forward. The advantage here, faster rate, because increasing directly, and more yield. But here, if we are increasing moves backward, the advantage, faster rate, but less yield. In case of lowering to be forward, more yield is produced now, but slow rates. Again, for the rate, if you are increasing any factor, rate increasing. So increasing, rate increases. Increasing, rate increases. Decreases, rate decreases directly. For equilibrium, by increasing, moves from 4 to 2, forward, more yield. By increasing, moves from 3 to 2, backward, less yield. So we must to decrease to make it moves forward, produce more yield. But here, this advantage, more yield, but slow rate. The other one, faster rate, but less yield. In case of equal number of moles, 2 and 2, no effects. Why no effect? Equal number of moles in both sides, equilibrium. Equal number of moles in both sides. Okay. After that, temperature. In temperature, it depends on the type of reaction. Endothermic or exothermic. In endothermic, heat absorbs. Exothermic, heat is released. How can we know this is endothermic or exothermic? In endothermic, reactants plus heat to form products and delta H equal positive. In exothermic, reactants produce product plus heat and delta H equal negative. Like, for example, if you have H2 plus I2 gives 2HI and delta H equal positive 59 kilojoules. C plus O2 gives CO2 and delta H equal negative 373 kilojoules. Or plus heat is here, or plus heat is here. In this case, in endothermic reaction, if you are increasing, the reaction moves forward. In exothermic, if we are decreasing, reaction moves forward. Why? Because no need more no need for more energy. So the summary for this part, and concentration to make the reaction moves forward to obtain more yield. And concentration, adding reactants or lowering products. And pressure, number of moles. Reactants greater than products, so are increasing. Reactants less than products, decreasing. Reactants equal products, no effects. Temperature. And temperature, it depends on the type of reaction. Endothermic, so we are increasing. Exothermic, so we are decreasing. Applications for rate and equilibrium, Haber process and contact process. In Haber process, it is the preparation of ammonia and 2 plus 3H2 gives 2NH3. In contact, preparation of sulfur dioxide, sulfur trioxide, 2SO2 plus O2 gives 2SO3. Both reactions are reversible. Both reactions are exothermic. The conditions for the reactions, temperature, pressure, and catalyst. Temperature is 450 degrees Celsius for both. Pressure, 200 atmospheric pressure, and 2. Catalyst, iron, catalyst, vanadium pentoxide. In these conditions, we are using low temperature, high pressure. We are using low temperature, high pressure, and adding catalyst. Explain why. Number one, why we are using low temperature? Because the reaction is exothermic, delta H equal negative. So by lowering temperature in exothermic reaction, we must lower. So because the reaction is exothermic, so by lowering temperature, the reaction moves forward and more yield is produced. So because the reaction is exothermic. So by lowering temperature, reaction moves forward and more yield is produced. Number two, high pressure. In high pressure, we are using high pressure if the number of moles of reactants is greater than products, so the reaction moves forward and more yield is produced. We have 4 and 2, 3 and 2. So the number of moles of reactants is greater than products. The number of moles and reactants as greater than products. So the reaction moves forward. So by increasing pressure, the reaction moves forward and more yields produced. Okay, this is high pressure. Adding catalysts. Why you are adding catalysts? To speed up the reaction. For the catalyst affecting only the rate, not equilibrium. So speed up the reaction for the rate, not for the equilibrium. So this for Haber and contact. In Haber, N2 plus 3H2 gives 2NH3. In contact, 2SO2 plus O2 gives 2SO3. Temperature 450, pressure 202, catalyst iron and vanadium pentoxide. We are using low temperature, high pressure, and the catalyst. Low temperature because the reaction is exothermic. So by lowering, the reaction moves forward and more yield is produced. Pressure, high pressure because the number of moles in reactor is greater than products. So by increasing pressure, reaction moves forward and more yield is produced. Catalyst to speed up the reaction. After that, preparation of sulfuric acid. Sulfur reacts with oxygen to form sulfur dioxide. Sulfur dioxide reacts with oxygen to form sulfur trioxide. By adding water, it will form sulfuric, but this explosive. So we're adding sulfuric acid, H2SO4, to form oleum, H2S2O7. This is called oleum. By adding water to the oleum, sulfuric acid is formed. After that, we said for fertilizers. The best fertilizer that contains NPK, nitrogen, phosphorus, and potassium. This is the best fertilizers. Forming NPK, nitrogen, phosphorus, and potassium. For catalytic converter, we are using catalytic converter to change two harmful gases, carbon monoxide, that reacting with nitric oxide and the presence of platinum used as a catalyst to form carbon dioxide and nitrogen. Two harmful gases change to harmless gases. This is for purification of gases in air. Carbon monoxide, as we said, this toxic gas combined with hemoglobin in blood decrease the ability of respiration. And nitric oxide and also sulfur oxides causing acid rains that causing death marines, death plants, and decay building, rusting metals, affecting respiratory system. So carbon monoxide and nitric oxide harmful gases, it change into two harmless gases, carbon dioxide and nitrogen. For sulfur oxides and nitrogen oxides, they are forming acid rains. Acidic rains forming death marines, death plants, rusting metals, decay building, and affecting respiratory system.